Okay, so this is about a balloon, something like this. So if you just consider a balloon like this and a person inside the balloon is now playing with a stone, right? That is what it says. The balloon is moving upwards with 15 meters per second. So we'll take the velocity, upward velocity of the balloon as 15 meter per second, right? It is 15 meter per second. And then it says uniform vertical velocity. A stone is freely released from the balloon at a point 200 meter above from the ground. So the ground level is also mentioned. And at the moment the stone released freely, it is 200 meters above the ground, something like this. So I mark the height like this. And so one stone is actually released from rest from the hand of this person. However, remember, this stone also have the 15 meter per second vertical upward velocity because it was in the balloon, the system of balloon and the person. And what will happen to this stone? It will go up, right, under gravity and come back to the ground. Actually, it will go up until its velocity becomes zero, right? Until its velocity becomes zero, and then it will come down like this, okay, and reach to the ground. That is the motion of the first stone. As it mentioned, we can consider it as A or something. And at the same moment, a separate stone is thrown vertically downwards with 15 meters per second vertical velocity. So another ball or stone, we can mention it as capital B, 15 meters per second vertical velocity by the person or another one. So this is just released, right? The first one. Then we have to change the velocity. This one should be in the upwards direction. However, I'm just thinking this 15 meter per second upward velocity is relative to the person, right? Relative to the person. At the same time, this balloon is also moving with the 15 meter per second at the time it threw out this second ball. Therefore, there should be a addition of another 15 if you consider relative velocity with respect to the earth, right? Therefore, we have to have an additional 15 because initially we don't know, because it doesn't say anything about whether the 15 meter per second relative to the ground or relative to the balloon. So if it is like that, if it is thrown upwards with the by spending energy, right? This person has to spend some energy to throw out it. And releasing the ball is actually without any effort, he just released. But throwing upwards mean actually it should be relative to the balloon. Okay, right. So therefore, we have to have an additional 15 meter per second here for the second ball. Therefore, it should be moving with 30 meter per second at the initial position. So it should go up further because the initial velocity is double the velocity of A. So it will go a little bit further above and come back and reach to the ground. So this is what we have to consider when you deal with the problem. So the first part, as seen by the man on the ground, what is the velocity of the first stone? So what it mean? What is the velocity of the first stone? Mean what is the initial velocity? Probably, right? So part one, it should be the initial velocity, I think, because otherwise you cannot ask what is the velocity. Right. So room number one, part A, what is the velocity of the first stone? So velocity of A, we can denote with a relative velocity notations. Velocity of A relative to the ground. If a person here at the ground, we can denote him as capital E. So this, the first one, initial velocity of stone A is just 15 meter per second, right? Upward 15 meter per second. That is what we can say about the initial velocity of the first stone. Simple B, what is the velocity of the second stone? So VB relative to the earth. Now we can see the second ball will move with two velocities, right? First one is the velocity given by the person, and the second one automatically comes with the motion of this balloon. So therefore it should be 30, and it is also moving upwards, 30 meters per second. So these are the answers for the first part. Second part, from number 2. What is the time taken by the first stone to reach the ground? Right. So actually the first stone, that is stone A, will move up and reach to the zero velocity at the topmost point and come back to the ground, right? So the starting point is just 200 meter above the ground. Therefore, straight away we can apply the equation upwards, something like S equal ut plus half at1 square, right? Using the equation S equal ut plus half at square. Directly we can find the time it takes. However, we have to carefully substitute the values. So these are the values substituting. S equal, right. Now this is the starting point and this is the end point. And if you use S equal ut plus half at squared upwards, the total displacement for the part stone capital A is minus 200 meters, right? Because into the direction, we are using this equation, upward direction, the total displacement after some time, simple t, the total displacement should be 200 meters. So this is actually what I am going to do. I am going to use a single equation to find the total time. One can do it in this way also. If you consider the highest point where the stone capital A reach, then you can find the time for reaching to the highest points as t1. And from that point, we have to consider the downward motion and consider it as the time t2 and we have to add those two time values, T1 and T2. But this will allow us to calculate the total time straight away. So initial velocity should be the 15 meter per second, because we have to consider it relative to the ground. Just after releasing from the balloon, there is no any connection with the motion of the balloon. Therefore, we have to substitute u as upward direction 15 meter per second. And since we are using the equation upward direction, the acceleration should be negative. So A should be minus g, right? Minus g mean minus 10. A should be minus 10 meter per square second. Then we can find the time, right? We consider the time as simple t. So if you substitute minus 200 is equal to u is 15 times simple t minus half times a equal 10 minus 10 actually times t squared. Right, so we will have a quadratic equation of t. Right, here we have pi t squared minus 15t minus 200. If you bring all the things to the left hand side, something like that. Even we can divide the whole equation by pi, so that we have t squared minus 3t minus 40, I think 40 is equal to 0. Then we can factorize that. T squared will comes like t and t. Then 8 and 5 should be here. To get minus 3t, this should be minus and this should be plus. So this is equal to 0. So easily we can factorize it. However, from this, we can obtain t equal 8 second or t equal minus 5 second. So this is not acceptable, right? Therefore, the correct time should be, so the time takes, simple t should be 8 seconds. So we neglect the second answer because it is negative, because we are calculating a time. So after 8 seconds, right, ball A will reach to the ground. Third part, what is the time taken by the second stone to reach the ground? Similarly, we have to calculate by considering the initial velocity as 30 seconds, right? Initial velocity as 30 seconds, and see whether we can calculate the time in a same manner. Row number 3. Again, using upward direction, s equal ut plus half a t square. Right, we can directly substitute the total displacement from the point of releasing, not releasing, but this is thrown vertically upwards. That point is 200 meters above. So even the second stone should reach to the ground after spending some more time than capital A, right? But same vertical displacement of minus 200. So directly we substitute minus 200 for this. And initial velocity is not 15 but 30 times simple t minus this part is same, half into 10 and t squared. Okay, so here we will have the quadratic equation as before, just looking at the first part. 5t squared minus 15t. Instead of 15t, we have 30t. Minus 200 is still there. Is equal to 0. At this time, actually, if you divide it by the whole equation by 5, you will get something like t squared minus 6 minus 40 is equal to 0. So, is it possible to factorize again? 40 mean 8 into 5. So, 5 will not give the value minus 6. What else? 4 into 10? Yes. 4 into 10 will give the another factorization for this quadratic equation. And see, t and t should be here. So if you multiply 4 by 10, we will get 40. And to get the minus 6, this should be minus and this should be plus. Right, is equal to 0. And from this, actually, we have two answers. T equal minus 4 second, not acceptable as before because it is negative. Or t is equal to 10 second. Right, in this case, the time it takes to reach the second object to the ground level is actually given as 10 second. So t must be equal to 10 second in this case. Okay, right. Fourth question. What is the time difference between the above 2 and 3? Right, the time difference between the 2 and 3 should be only 2 seconds. So we have the answers, therefore easily we can get the time difference. Time difference we can consider it as delta t. Delta t should be 10 seconds minus for the first one 8 seconds, and that will be 2 seconds. Okay, right. So this is another answer. So we have done that part, part A actually of the third question related to the relative velocities. Okay, and see what is the second part. So we have another question, part B. A battle aircraft is flying at a velocity 72 meters per second at an elevation of simple edge 128 meters to attack an array of identical trucks moving along a straight road with different constant speeds. The dimensions of a truck is about 10 meter in length and 3 meter in height. At the instant a bomb is released freely from the battle aircraft as make 120 meter horizontal displacement with the rear edge baggage of the truck. Find the velocity of the truck if it was completely destroyed. After a few seconds, another bomb was released freely, targeting another truck of uniform velocity 45 meters per second. At the instant of bomb is released, the rear edge of the truck also a horizontal distance as above case. Will it be destroyed or not? You reason for your answer. Right, it is something like projectile motion. Again, a battle aircraft is flying at a velocity of 72 meters per second at an elevation of 128 meters. So it is something like this, right? Aircraft is moving with 72 meters per second, right? And the ground level is just 128 meters below. So this height is given 128 meters. Okay. And it says to attack an array of identical trucks moving along a straight road with different constant speeds. The dimensions of a truck is 10 meters in length and 3 meters in height. Right, so dimensions are also given. So if you just consider a truck like this, right, moving in a straight road with the particular velocity, we don't know because it says with different velocities, but moving forward direction, we assume that like that. Then the dimensions are given like 10 meters and 3 meters in height. Right, 3 meters in height mean the projectile will not actually reach to the ground and hit the truck just about 3 meters from the ground. That is what we can get. And there may be a tolerance of 10 meters to hit the bomb on a truck like that, right? Then at the instant of a bomb is released freely from the battle aircraft as make 120 meter horizontal displacement with the rear edge, back edge of the truck. Okay, so that is the distance we need because from the rear end, right, this is the so-called 125 meter distance. And when a bomb is released, right, from this aircraft, we know that again, when it is released, the bomb also having a velocity, initial velocity, horizontal velocity like 72 meter per second as the initial velocity, and it will follow a projectile path and it should fall on this truck, right? However, remember the truck is also moving, right? Therefore, in this case, we have to consider the relative velocities, otherwise very difficult. Okay, so it says 120 meter horizontal displacement with the rear edge, back edge of the truck. Okay. Now, actually, we can consider, we don't know which tolerance we should have because 10 meter, it doesn't matter it hit the rear end or front end or within this 10 meter. I don't know why 10 meter is given. Okay, right. Now, find the velocity of the truck if it was completely destroyed. Right? If it was completely destroyed, how can we say that? What is the condition for the completely destroyed? I mean, if a bomb fall on the rear end, maybe not completely. And the first front end, maybe not completely. So shall we take it as at the middle? We don't know. Right? It is a very tricky condition to satisfy. But if you consider another 5 meter, I think it is okay with the 125 plus 5 meter, right? Assume that the required horizontal range should be 130 meters, right, to the middle of the truck. If the bomb is just fall at the middle of the truck, we have to have 125 plus 5 meters. Right? Let capital R should be 125 plus 5 meters for completely destroyed. එක අපේ condition එක for completely destroyed, because we don't know what is the meaning of the completely destroyed mean. The truck, right? However, now since it is moving with the horizontal velocity of v, we have to consider the motion of the bomb relative to the truck, right? Consider the motion of the bomb relative to the truck. That means we have to stop the motion of the truck. For that, we have to give a similar velocity to the opposite direction. Say simple v. Now, truck is at rest. Then we have to give the same velocity to the bomb, to the backward direction, simple v. So now, bomb having the velocity forward direction 72 minus v. And it should move 125 plus 5, that is 130 meters. During its fall under gravity, 128 meters. Because we can see when it released from the aircraft, it is moving downwards with initial velocity u equals 0. And it has to fall down 120, at least 125 meters, because 3 meter height is given for the truck. We don't know. It will probably fall on the roof of the truck, just 3 meters above. Therefore, even 128 meter does not necessary to fall down. 125 meter is enough. Okay. So by considering all these things, we can apply an equation to find the time it takes to fall down, or the time for the projectile motion, right? Using an equation downward, something like S equal ut plus half at squared, we can find the time it takes to reach to the truck, right? So for the S, actually, we are going to substitute 125 by subtracting the 3 meters from 128. So it will become easy for the calculation if you use 125. So initial velocity is 0, therefore this term is not there. Half times A should be 10, and this should be t squared, right? T squared. Okay, so here we have 10 will cancel out with 5t squared is equal to 125. We know that then t squared should be equal to 25, right? Because 125 divided by 5. That means the time it takes to reach the truck is just 5 seconds. Right? During these 5 seconds, at least the bomb should travel a distance 130 meters. Right? 130 meters. So if you use an equation forward direction, something like S equal ut plus half at squared again. But we know that there is no horizontal acceleration under gravity. Therefore, only we have s equal ut terms, right? So the time distance should be 130 for complete destroy. The truck should be equal to u. Initial velocity should be the relative velocity 72 minus v, right? So v comes here 72 minus v times the time is simple, t is equal to 5 seconds. Another term should be equal to 0 because there is no horizontal acceleration. So 130 should be divided by 5, right? Then we can see 72 minus simple v is equal to 130 divided by 5. So we know that we have 13, 10, that is 2. And for the 30, if you divide by 5, we have 6. So altogether 26. So if you solve this to find the value of v by taking v other side and 26 to the left hand side. So it is 72 minus 26, right? So that is, if you take 12, here we have 6, and then 6 minus 2 is 4, 46 meter per second. So this is the speed of a particular truck we are considering here for the first part. The truck is moving with 46 meter per second in the ground, and the bomb will fall down just middle part of the truck. That 5 meter we have taken with the horizontal range of 125 at the time the bomb release, right? If you try to do it without considering the relative motion, you cannot do the problem because while it is moving, while the truck is moving, the bomb is going to be released. Therefore, to do this type of problem, we have to consider the motion of the bomb relative to the target. So target is the truck. Therefore, we are going to stop the truck. Now you can see by giving the velocity to the backward direction, this can be considered as at rest. This is now at rest, right? That is what we call the motion of the bomb relative to the truck. Okay, that is the part A, right? Find the velocity of the truck if it was completely destroyed. Right, see part B. After few seconds, another bomb was released freely, targeting another truck of uniform velocity 45 meter per second. At the instant the bomb is released, the rear edge of the truck also at a horizontal distance as above case, that is 125 meters. Will it be destroyed or not? Give reasons for your answer. Right. Now, after few seconds, mean aircraft should move some distance away from the first point of release of the first bomb. Right? It is somewhere here. And start and release another bomb. And this case, actually, we don't need to consider the time because time calculation we have already done. It takes 5 seconds to really reach the ground for every bomb. If you assume that the aircraft is moving horizontal distance above the ground 128 meters without lowering or going upwards. If it is moving like that, right? Because we have to have another diagram. Okay, we have to have another diagram. But the time it takes is 5 seconds. So we can use that information without calculating it again. So after some times, right, after some times, another bomb is going to be released by targeting another truck. This is the second bomb. Again, the bomb should have initial velocity of 72 meter per second, as the velocity of the aircraft is also 72 meter per second. Right. Now, again, at the time of release, another truck is moving with the velocity of 45 meter per second. It is given, right? This is moving with 45 meter per second with the same type of truck. Okay. And now we have to stop this truck also to consider the motion of the bomb, second bomb, relative to the truck. For that, we have to subtract 45 meter per second. Then we can see the second truck is now at rest. And if you want to see the relative motion of the bomb, right, then we have to give the same 45 meter per second velocity to the reverse direction for the bomb also. And now, as before, it says at the time of release, the rear end of the second truck is also 125 meters away from the level of the or the position of the aircraft, right? So now we have to verify that, or we have to show that whether this will be hit the target or not, right? Hit the target or not. Okay, so we know that time takes, right? Time taken to reach the ground level equal 5 seconds as calculated before. We don't need to calculate it again. And see the relative velocity of the bomb, horizontal velocity of the bomb, horizontal velocity of the bomb actually relative to the truck, right? Is equal to 72 minus 45, right? 72 minus 45. So you can see it is 7. From here, 6 minus 4 is 2. 27 meter per second is the relative velocity of the bomb, right? And we can check whether during this 5 second, if the bomb having the 27 meter per second, whether it can travel the distance, the minimum distance, just to hit the rear end, 125, and then each meter it can move further. It can destroy this truck completely or partially, but at least we have to have 125 meters distance during the 5 second of time if the horizontal velocity of the bomb is 27 meter per second. Okay, right. Then using the equation in the horizontal direction is equal ut plus half at squared, and if you substitute the time as 5 seconds and the velocity as 27, we can calculate the horizontal displacement u equal 27 into 5 plus the other terms will not come, right? So what is the value? 7 times 5, 35. 5 should be there, 3 is there remaining. 5 into 2, 10 plus 3, 13, 135 meters, right? 135 meters, right? It is more than enough. Oh, just reach to the front edge of the truck, right? We cannot say whether it is destroyed or not. I mean, the road will destroy it probably, right? So if you consider this distance of the truck or the length of the truck as 10 meters given, exactly it falls just in front of the truck, right? 125 and 10, 135. So we cannot exactly say, but at least we have to say something, right? We can say it will hit the ground just front of the truck. So we can say something like that, right? Because the distance 135. And the time 5 seconds, we have calculated just to reach about 3 meters from the ground level, right? That we have considered, right? So that is how we complete the second part of that question. See the part B of that question. The AB, what is AB? A and B are a string, right? The AB string is fixed on a vertical stance and a pulley as shown in the diagram. 15 Newton and 12 Newton weights are suspended at capital B and capital C respectively, right? Calculate the tension of the string of AC segment and inclination theta to the horizontal, right? And that part is just finished after that, right? Okay. Here we are going to deal with part D of that question. Okay. So we have to find the tension of the string of AC segment and the inclination theta to the horizontal. And see, the string capital AB, it seems that the string is a single one and it should be light string, massless string, right? However, because of the connection here, we cannot consider the total, I mean, the tension throughout this string is constant. We have to consider this as 2 parts or maybe 3 parts of the string connected at the point capital Z. Therefore, when you mark the forces, right, we have to carefully do that. Okay, so we have to consider this force, right, 15 newtons at this point is equal to the tension T1 where it will go like this up to this point. So even at point C, you can mark the tension T1. And because of the equilibrium here, the force T1 should be, or the tension T1 should be 15 newtons. At equilibrium, you can say T1 is equal to 15 newton. Okay, right. Then we come to the another tension which can be considered as the tension of this part AC. So we can consider it as T2. And here also we can mark T2. Right? And what else? I mean, you can consider this part as another tension. Or otherwise you can directly use this as 12 Newton force. Right, downward 12 Newton force. Right, I can mark it like this. Or otherwise we have to have another tension. Doesn't matter. We assume that this 12 Newton force should be act on this point C. Okay, right. Now, see, considering the equilibrium at point C, we can balance the vertical and horizontal forces because T2 will make a horizontal component to the left hand side, which can be considered as T2 cos theta. Right, so I will mark that force to this direction, maybe with some other color. Okay, this color. Okay, it will make T2 cos theta, and at the same time it will make another component, that is T2 sin theta. Right, so we can cut down this T2 because we are going to consider its vertical and horizontal components. Right, now we can consider the equilibrium at point C. At point C, the vertical component T2 sin theta must be equal to 12 Newton. That is equation 1. And T2 cos theta should be equal to T1. T1 is actually 15. So therefore, this is the second equation. And if you divide these two, 1 divided by 2, we can find the sin theta divided by cos theta, that is equal to tan theta. And it is equal to 12 divided by 15. If we divide this by 3, it is 4 divided by 5. So theta is actually given by tan inverse 4 divided by 5. And if you use the logbook, actually we can find the value of theta. But for a question like here, I think we can, the direction theta is given by tan inverse 4 by 5 is enough, right? That's the answer. Okay, so that is the direction, but we haven't calculated the tension yet, right? T2. So T2 should be from the equation 1, from equation 1, we can subject the tension T2 as 12 divided by sin theta. Right? If you use equation 2, T2 should be 15 divided by cos theta. Right? So whatever the equation we use, equation 1 or 2, we need to know the values of sin theta and cos theta to substitute here and get a numerical answer. So what can we do? Because we know the tan theta. So if you know the tan theta, we can find sin theta or cos theta by considering a small triangle like this, right? And mark in the given tan theta value. So tan theta, if you select the tan theta angle here, tan theta means the front side divided by the adjacent side. So the front side can be considered as 4 while the adjacent side can be considered as 5. So 4 divided by 5. Otherwise, we have to find the angle, real angle. Okay. So then the diagonal of this triangle should be equal to 5 squared plus 4 squared, right? 25 and 4 squared means 16. It is 41, right? This should be square root of 41. Then we can calculate the tension T2 as 12 divided by sine theta. Sine theta mean 4 divided by square root 41. Then square root 41 comes out. 41, right? That means actually 3 times square root 41, right? We cannot keep this value like this. We have to find the square root of 41. So if you try to find square root of 41, 3 into 6.40. And if you multiply it by 3, 6.4 into 3 is equal to 19.2. 19.2 in newtons. Right? We have to use the logbook to simplify this. Square root 41 is 6.40. At the same time, if I look at the value 4 divided by 5, it is 0.8. So we need to calculate tan inverse 0.8 is equal to roughly about 38 degrees and 39 seconds, right? So theta is given as 38 degrees and 39 seconds, something like that. And if you know that angle, you can directly go to the sine theta and cos theta with the logbook or trigonometric chart, right? So that is the way we have to calculate the tension at this part. Okay, so we move to the part C. It says a 70 kilogram mass of a man stands on a balance which is fixed in an elevator that is moving vertically upward direction. The elevator starts its motion with rest and 3-second time period with 4 meter per square second acceleration. Finally, it becomes rest with uniform retardation. Weight of the man was indicated as 490 Newton when it is moving with the retardation. Okay, right. So we know that if an elevator is moving vertically upwards or downwards with an acceleration or deceleration, the effective G value is going to be changed. For the weight of the mass, a person should be different while it is moving with an acceleration upwards or deceleration, or actually we can show that the weight is same as the weight of the object or person like this, while it is at rest, while the frame, that is the lift or elevator, is at rest, or while it is moving with the constant velocity. Unless it is at rest or moving with the constant velocity, while it accelerating or decelerating, the weight of an object inside this type of frame will give a different value. Right, here we have an elevator, right? We can consider it like this, and a person with mass 70 kilogram is just inside, right? The mass of this man, simple M, is just 70 kilogram. Right. Now, what is the weight of this person and how it affects the motion of this elevator? For example, if you just consider the weight of the person, we can mark it as mg. It is just on the man. And there's another important thing, that is the reaction from the elevator to this person, that is normal reaction, can be considered as capital R. So when the elevator is at rest, right, we can say R is equal to mg. It is not going to change, right? R is equal to mg. That is the real weight of the person. But when it is moving upwards or downwards with an acceleration or deceleration, the R value may be different from the real weight. For example, if you consider if the elevator is moving upwards with an acceleration of simple A, we can apply F equal ma to all the object inside this frame, right? So using upward direction F equal ma, if you consider this person, the forces in the forward direction or upward direction is R minus simple mg is equal to ma. And we can see the normal force experienced by the person is now greater than his weight because it is moving with an acceleration. It is equal to mg plus ma. Or otherwise, sometimes we refer it as m times g plus a, right? R is equal to m times g plus a. Or we can say R is equal to m, that is property of the person, mass. However, here we are going to represent g plus a as g dash, right? Where g dash is referred as effective value of g, effective g, effective g, right? Effective g. It is not really the g value we experience, that is 10 meter per square second, but it is something different. It is equal to g plus a, right? It is equal to g plus a. Okay, so now we move to the problem. 70 kilogram mass of man stands on a balance which is fixed. I mean, it doesn't matter if you consider a balance or not. We can see the R value, it will be greater than the weight of the person, right? Which is fixed in the elevator that is moving vertically upward direction. The elevator starts its motion with rest and 3-second time period with 4 meter square second acceleration. So initially it is accelerating, right? Finally it becomes rest with the uniform retardation. Weight of the man was indicated as 490 Newton when it is moving with retardation. Okay, 490. Calculate the apparent weight of the man when the elevator is moving with acceleration. Right? Okay. So what is the acceleration? During the first 3 seconds, it is moving with the acceleration of 4 meter per square second. So if it is moving with an acceleration, this is the reading one can get from the balance. Oh, it says a balance, right? On a balance. So the balance එකේ පේන reading එක තමයි R equal mg dash කියලා කිව්වේ. Where g dash is actually g plus a. So this is what we call the apparent weight of the man while it is moving upwards. Room number 1. Where the apparent weight can be considered as R actually is equal to simple m times g plus a. And if you substitute for the m 70 and g must be equal to 10 plus we can see the acceleration 4 meter per square second. It should be 4. So 70 into 40, right? If you multiply 70 by 14, we can see it is 980 Newton. 980 Newton. So this is the apparent weight. But it should be, because the mass is 70, the real weight when the person is at rest should be 700. But it give us, the reading give us something like 980 when it is accelerating. Okay. Second part. Find the displacement moving with acceleration. Find the displacement moving with acceleration. Right? The displacement moving with the acceleration, if you apply something like s equal ut plus half at squared. Okay. Then we can calculate the displacement simple as so during the acceleration period, right, it says the elevator is starting at rest, right? At rest and moving with this acceleration 4 meter per square second about 3 seconds. 3 second time period. So this is equal to 0. Then half. It is moving upwards, right? It is not moving under gravity, but the elevator is actually controlled by a system of pulleys, and it can maintain upward direction of acceleration 4 meter per square second. Therefore, acceleration must be 4. And the time it takes 3 seconds, square of 3, because t squared is there. So the displacement, vertical displacement of the elevator should be 3 squared, that is 9. 9 times 10 is 18 meters. So this is the displacement during that 3 second time period. Find the maximum velocity obtained by the elevator. Okay. Part 3. Maximum velocity mean the final velocity. So if you apply the equation something like v equal u plus at, after 3 seconds, the velocity is given by v equal u equals 0, acceleration is 4, and time is 3 seconds, right? Then 4 into 3 is 12. So the v max should be the final velocity. V max should be 12 meter per second. That's the third part, right? And the fourth part. Find the value of the retardation of the elevator. So the elevator starts its motion with rest, and 3-second time period with 4 meter per square second acceleration. Finally, it becomes rest with uniform deceleration. Finally mean after reaching to the maximum velocity and acceleration, then it start to deceleration or retardation. Weight of the man is 490 is given. Okay, so we have to consider just after completing the acceleration part, it is going to be deceleration. Find the value of retardation of the elevator. So how can we find the retardation? Because finally it becomes the rest with uniform retardation. Weight of the man was 490. Something it says, right? Okay. Weight of the man was indicated as 490 when it is moving with retardation. Okay. So now consider what is happening. How can we use the apparent weight of a person inside an elevator like this? Okay. Now person is still there. Now actually this is moving upward still with a negative acceleration. That is what you call the retardation. Minus A. It is going to be stop at a particular level. So that is why it is moving with minus A. So we have to find the value of this A magnitude. For that, it is given the weight. We can just consider weight as mg. And the apparent weight, actually, that is the value of R. And it is given something like 490. Right? When it is, when the elevator is retardating, the weight of the person is observed as 490. So R is equal to 490, in this case 490 in Newton. So if you apply F equal ma, upward direction, right, F equal ma, then we can write capital R minus mg at the resultant force, which is equal to simple m times minus a. So that is negative term. So R is equal to now mg minus ma, and we can consider it as m times g minus a is equal to R. So given that capital R is equal to 490, right? So we can substitute the value of capital R, 490, is equal mass of this object or the person is 70 kilogram. So we have to substitute 70 here, and G is 10 minus A. This is what we have to calculate. So 0 can be cut down. We know that 49 divided by 7 is 7, right? So 7 is equal to 10 minus A. And we can subject simple A by taking that into the left-hand side. So E equal 10 minus 7. So 10 minus 7 is 3 meter per second. So the deceleration or retardation magnitude is equal to 3 meter per square second. Right? Find the value of the retardation of the elevator. So that is the magnitude of the deceleration. So since it is deceleration, we use it as minus A. And here we subject simple A, the magnitude. it is equal to 3 meter per square second, right? Okay, so that is the fourth part of that question. And finally, find the displacement moved with uniform retardation. Find the displacement, right? After finding the value of simple A, to do that part, that is part 5, we need to find the displacement. If you apply V squared is equal to U squared plus 2As, something like this, even by using this equation, we can calculate this. We know that we have to have a rest at last, that is the final velocity, should be equal to 0. And initial velocity should be 12 square of that, plus or minus, it should be minus because it is a retardation, deceleration. 2 times, we have found the magnitude of the retardation as 3 meter per square second. But when we apply this equation upward direction, we have to take it as negative 3, right? Times s. Okay. From this, we can calculate the value of s. S should be equal to 12 square, that is 145, right? Sorry, 144. Divide by 6, right? 2 times 3, 6. 6x. Then we have 144 divided by 6. Easily we can divide and get the value of 4. That is 24. 24 meters. It should go up with the decreasing velocity or deceleration or retardation, 24 meters. So that is the last part of that question, right? Find the displacement move with uniform retardation. Okay. There also we have upward motion and not under gravity, but the elevator having acceleration and deceleration, right? The apparent weight is different from the weight of a person, especially when it is accelerating or decelerating. Okay,